Welcome to the Cosmic Pie Podcast, Season 2, Episode 17. I'm your host, Wayne Barkhouse, and with me, as always,
Robert Moore.
we are broadcasting live from the campus of the University of North Dakota here in Grand Forks, North Dakota.
Yep.
We do have a live chat that's running, so if you have any comments or questions you'd like to send in to Robert and I, please use that feature. Also, as we always say at the beginning of these podcasts, at least we try to remember, is that anything that Robert and I say are our own personal opinions and not necessarily the opinions of the University of North Dakota nor anyone affiliated with them. So, Robert, I guess we'll start with the big news.
The big news,
The
right?
big news is this is the end of the semester. Officially tomorrow, I think, will be the last day.
Tomorrow's the last day?
Spring semester, yeah.
I figured today would be the last
No,
day.
the summer is the 16th of May.
Okay.
So if we want to go by the exact calendar date, then tomorrow would be the last day of the spring semester. Of course, our grades were put in
Today.
noon today is when they were due. So I think people are taking a deep breath at this point and relaxing. Things are over.
And that's kind of why we may be sounding a little tired, folks. So.
Yeah. Well, talking about taking a deep breath, we are going to take a deep breath.
Right.
Which is why I want to mention at the top of the podcast, in case you don't get a chance to watch it all to completion today or some other time, is that this will be our last podcast until September. So Robert and I are also taking the summer off from doing the podcast. We have lots and lots and lots of other work that needs to be done. So it's not like we're going to be having our feet up on the desk. Unless my laptop's on my legs laying, then it could be. But I've still got to work.
But it's still working, believe it or not.
We have a ton of work that needs to be done. And so we're going to take the summer off. So our next podcast then will be in September, and we'll advertise weeks ahead of time so then everybody will have a notification of when that occurs. Now, the biggest news, of course, Robert, is on Friday night, and that was worldwide type of news.
That was. And, wow.
Wow is a good way of expressing your view of that. In fact, most people, I think, wow was the first thing that came to the mind. And this is related to the activity of the sun. Now, the sun is ramping up to what we call solar max. Mm-hmm. This occurs on a cycle of about 11 years.
Yep.
And the thing about solar max is when the sun reaches solar max, that's maximum activity, if you like, there is way more sunspots at any given moment than at other times when we're at solar minimum. And the sun is also much more active, so there are more of these storms on the surface of the sun.
And that's what sunspots are, is they're massive storms.
Yeah, magnetic storms.
They're magnetic storms, yeah.
So you can have what we call coronal mass ejections, which is a sudden outburst of charged particles, plasma essentially, that escapes from the sun.
Right.
And depending on where the Earth happens to be and where this ejection process takes place on the sun, which side of it, it may or may not be headed towards our way. And we can also have solar flares. And some of these solar flares are extremely powerful, so they produce tremendous amount of high-energy X-ray photons, for
X-rays.
example. In fact, that's just happened today. We had a major solar flare that occurred from a very large sunspot, which you can see in this image of the sun. So this was taken by the SOHO spacecraft on a couple days around, I think it was May the 10th.
Mm-hmm.
Okay? And that large sunspot that you see in the lower right, that sunspot, occupies a dimension, a size about 15 times the size of the Earth.
Right.
So that's
huge.
Yeah, that's massive. When you talk about wow, there's a good use wow there to
Wow.
describe that. Now, this sunspot has just produced a huge X-ray flare, but as the sun rotates, it takes approximately 1 month for the sun to go around once.
Mm-hmm.
Right? It's a little slower, believe it or not, near the polar regions, a little faster near the equator. So this sunspot has rotated, so it's sort of side on to us now. It's just going behind the sun. But just before it did so, it produced this tremendous X-ray flare. Do you want to talk about some of the consequence of that today?
Well, it means we're getting a lot of radio blackouts. That's happening because it's coupled to our own magnetic field. And so all of that radiation and the protons, the charged particles that it gave off when it flared, have a direct stream essentially into our atmosphere. And this releases a lot of radio waves then when they impact the atmosphere and causes radio blackouts. We're probably not going to see any aurora from it because that usually takes a mass ejection. And the mass ejection would be it'd be here in a few days, and it'd give us a glancing blow at best with it pointed away from us. But the protons and other charged particles that are given off by that flare are definitely streaming into the Earth's atmosphere and causing all sorts of electronic disruption.
I know NASA released the fact that they classify these solar flares, so the higher the number, the more severe it is. So it's been classified as an 8.7, which is one of the most energetic solar flare that's been produced in a long time.
Yeah, I mean, I'm glad it was facing away from us.
And it just happened today.
Holy cow.
This is recent news. This is your
Right.
up-to-date type of stuff, current events happening. Breaking news. Breaking news. Yeah, well, this large sunspot was also responsible, of course, for the event that happened on Friday evening, our time, and that was a tremendous amount of solar activity responsible for the Aurora Borealis or the Aurora Australis, if you're in the
southern
south.
hemisphere, right?
So if you want to go to that next
Sure.
slide. So this was just ramping up. This is just a couple hours prior to being dark here in North Dakota. And you can see this is a prediction, a forecast map that's produced by the National Oceanic Atmospheric Administration, which gives a prediction. It's not always accurate, but it's fairly close, right, of where the intense aurora activity could be. And anywhere you see red, if you're a lover of northern lights, for example, this is a good thing. This is what you want to see.
Right.
And you can see that in places where it's really red, it's nighttime in those regions. That would cover, all of, a good part of Russia, through the northern Europe, Greenland, into eastern Canada. And it's just starting to get to North Dakota. We're actually in the green in this spot. But several hours later, that red rotated around, so it was right over us.
It rotates pretty much with the dark side of Earth.
So that was responsible, of course, for the big outbursts of aurora activity on Friday evening, which actually bled into somewhat into Saturday. In fact, Friday, before it was even dark, I was outside. We happened to have clear weather here in Grand Forks. And I was out just before it got dark, and I could just start to see the northern lights. The first time I've ever seen that.
Yeah.
And I've seen northern lights many, many, many times going way back to my early childhood.
You got to be in a dark location usually even to see it here.
Yeah, well, even if it just that it was so bright, right, that it actually was able to see it through the dusk, right? The sky wasn't as dark as what it would get, right, normally, let's say, compared to midnight, and you could already see the northern lights. It was amazing.
It was. It was a gorgeous thing, and, at its peak, I got to admit, I had friends of mine who were posting pictures of it where they lived down on the Georgia-Florida line. So it was seen deep into the south.
Yeah, I mean, we got a friend who's been on our podcast, Mal Blake, in Alabama, and he saw it down in... And there's reports of people way down in Puerto Rico actually seeing the northern lights.
That's incredible. I mean, that's just... Yeah.
And as far as I could tell, by looking what I was reading and stuff, this is probably the most powerful outbreak of aurora down south in the last 20 years or so.
Yep. And I will point out, for those of you who want to have some idea of when you might see aurora, there's a site called spaceweather.com, and they give forecasts about such things, and they keep track of various things, including what's called the KP index, which is from 1 to 9. And the higher the number, the greater an outbreak, a storm is. And the other thing is they keep track of BZ, which is the interplanetary magnetic field, the Z component of that. And when it's turned north, even if you've got a 7 or 8 on the KP scale, chances are you're not going to see much in the way of northern lights. But if it turns south and you've got a 7 or 8, you're going to see them as far south as what we saw, because that's where it was on Friday night. Was the KP was above 7. And the field was turned south.
And the other thing is that us here in North Dakota, in fact, our Department of Physics and Astrophysics, we do have an Aurora camera set up about an hour outside of the city. And we are live streaming on YouTube all of the time. In fact, the name of it is the North Dakota Dual Aurora Camera live stream.
Right.
So if you search for that, just type in North Dakota Aurora camera or something like that, you should be able to find that if you search within YouTube. And that allow you then to kind of monitor the skies from our dark location to see if it's worthwhile
To step
to
outside.
step outside, right?
And if it's really intense here, you might see it there. You know.
Well, if it's intense on the camera, because that's in
Yeah.
the dark site, then there's even a chance that you're going to see it even from within the city limits.
Absolutely.
So it's worthwhile to have a look at that once in a while.
And I will also say, yes, your camera will actually see it better than your eye will. And that's because even at its brightest, generally speaking, it's so dim, these northern lights are, that they're only activating the rods in your eye. This is in general. And what that means is you see it as a black and white, hazy, greenish color. You take your camera out, though, and your camera can be exposed for 2, 3, 4, 5, 20 seconds. And all of a sudden, all the reds and purples and greens will pop out. But that's why the camera sees it more. It's not some sort of filtering or anything like that. It is that you can get a longer exposure, so it activates the color receptors.
Now, on Friday evening when this was all going on, I contacted Robert, and Robert and I went out to Turtle River State Park
Right.
outside of the city to get into a little bit of a darker location. So we were able to get some images of the aurora from Friday night. And this is what Robert was talking about. So if you want to describe a little bit some of those images, Robert.
Okay. Yeah, sure. The one on the right was the one I took, and I was taking 5-second images. And
Do you want to explain what you were using? Because some people might
okay,
think you're
I was using my cell phone.
Yeah.
I was propping back up against Wayne's
car.
and to hold it steady and just taking a 5-second exposure. And that's what I got. Now, everywhere I got this type of image, all I could really see was a kind of a greenish haze on the sky. But when I took the 5-second exposure, all of a sudden, here's the reds and the purples popping out. And you were taking a bit longer exposures with your camera on a tripod, right?
Yeah, and that's the one you see on the left-hand side. So that bright spot you see near the horizon, that's actually the moon overexposed.
Mm-hmm.
And you can see the color, the northern lights, the trees. I gave it sort of the background that make it look a little cooler in some sense, right? So yeah, it was a great opportunity for people to practice, taking images.
Mm-hmm.
I mean, if you haven't taken images of the northern lights before, there is a little bit of fooling around for the settings.
Right.
I mean, what I was using was the DSLR camera. I don't think it was quite set up exactly the way I wanted. I did some adjustments after that, but I haven't had a chance to try it out, but I will.
I will admit that I started out with 3-second exposures, wasn't happy with the result, so I went up to 5. But when you're holding it, no matter how steady your hands are, you go above about 5 seconds, it's not going to be pretty.
Yeah, so the ones that I took here were on the order of about 25 seconds in length, but that's on a tripod.
Right.
And it's nice and steady, and I had a device hooked up that I could start the exposure without touching the camera so I wouldn't induce any vibration in the camera itself. But, if you take it for too long of a period, you'll get the smearing out effect. Of the stars will no longer appear around, but little streaks of light.
And the aura themselves are changing rapidly.
Yeah, so you'll get a little of a blurring of thing, right? So
Right.
you don't get the true detailed structure that otherwise that you might see. So the thing about astronomy, when we take pictures in the daytime, like just taking pictures on vacation, whatever, I usually set your camera to auto everything.
Right.
And it's made to adjust to the right settings so you get decent pictures. Don't have to think about all the numerous settings that you can fool around with. But, in astronomy and stuff that you're taking pictures at night, that's a different story. Then there is a lot of experimentation that you need to do with the settings to get the right thing. In fact, if you're unsure, what you could do is just look up go to Google or something and say, okay, what is the settings that I need for my camera to take an image of the northern lights? And a lot of times you'll see where people will give a recommended ISO number, an f-stop number, an exposure time.
And all of that is necessary. It's settings that change the iris diameter in the camera lens. They change how long the CCD takes before it sends an image to the computer that's on board, and things like that.
Yeah, even different formats. Some cameras you can save them in JPEG or you can save them in format.
Right.
image, right? The image sort of format.
AVI.
Yeah, there's all kinds of stuff, and that's designed that you can afterwards process those images with software. And if they're taken in one format versus another, one type of format allows you to do more detailed processing, where another format doesn't really allow you to do much of anything.
Right.
So there are all these kind of choices that you can make on those cameras. That's why the manual is about that thick. You see?
Right.
That comes with them. And how many people read, everything from cover to cover in those manuals? And it'd take you a month to read it.
It would. You tend to look up what you use.
Yeah, and the best thing, of course, one of the hardest things that I find is if you do have a camera like that, is the focusing. Because it's very difficult to manually focus to infinity.
Right.
Unless your camera is set up for that kind of a focus, but mine isn't. And so what I had done is I had focused on the moon earlier that evening.
Right.
And kept that focus. In fact, people tape their focusing ring so it doesn't move.
Yeah.
During the
I had thought of that.
when
That's
you're
a good
transporting your camera somewhere, like we did out to the state park, and hopefully the focus doesn't change. But that can be difficult. It's hard to get a real detailed focus. Yeah. And what you do is you end up experimenting.
And part of why it's hard is because you're trying to focus on small, dim objects, stars. Even the moon is not anywhere as bright as the sun, so it may look at night, but that speaks again of something we've talked about on this show, and that's the incredible dynamic range that your eye has.
Yeah, and the trick I always use for focusing is one which, if you're focusing on a star, you could turn the focus and then the star gets larger and larger in size. That means it's out of focus more and more. So reverse that operation, go the other way. And you'll find that the star gets smaller, and then if you keep going, then it starts getting larger again. So you want to get it for where the star has the minimum size. That's when it would be in focus.
Right. And generally speaking, on the little LCD screen on the camera itself, you're not going to be able to see the stars. So you really need to have it hooked up to some computer or something where you can see a big version of the image.
Yeah, and my DSLR camera I have, you can go live. So you can see the live image.
Right.
But it's still very tiny, so it's very difficult to judge what is the perfect focus.
Right.
So that alone, it takes a lot of fooling around if you like to get it right. So don't, if you get something and everything was out of focus, don't fret about it. Keep trying. You'll get it after a while. It takes a lot of
It takes practice.
Yeah.
It's like anything else in life. It takes practice. But the reason I mentioned about the colors and it was a matter of exposure time is I've heard a lot of people going, oh, that's fake, that's filters, that's this, that, and the other. No, it's just exposure time. This is the difference that going from 1/20th of a second that your eye does to 5 seconds. So keep that in mind. This is a lot of what goes on and notice how overexposed the moon was in Wayne's picture. These are all things to take into account when you're looking at images of the night sky.
Yeah, and the best thing to do, of course, is practice in the daytime.
Oh, yes.
Don't wait until you're actually somewhere, because you may spend all your time adjusting your camera, trying to get the right perfect picture, and you lose out looking at the event.
Yeah.
And the solar eclipses are notorious for that, because they are relatively brief, only a few minutes, and people may spend a lot of time messing around with their cameras trying to get the perfect picture and then miss the event altogether. So you don't want to do that. So do it ahead of time.
Do it ahead of time.
Yeah.
That's the best thing. And you can focus your camera to infinity in the daytime as well. You just pick a really distant object. And when I say really distant, I mean as far away as you can possibly aim.
Yeah, I mean, you could think of even an airplane very far away that you can
Right.
see, right? Focus on that, for example.
Right. And you'll still be a little out of focus because stars are that much further away. But you'll be a lot closer than your azalea bush.
Well, it's too bad that these cameras, even the cheaper ones that I bought, because I can't afford the big thousands and multi-$1,000
Right.
DSLR, don't have a setting for infinity that's accurate.
Right. It is a shame.
Because that would allow you to take, most of the photos in astronomy. We want the cameras set, if not all of them, set to infinity.
Right.
So,
I mean, a camera on a telescope, if you're shooting the moon, you don't want it set to infinity.
That's right.
What we're talking about. The moon through a telescope is actually close enough that you need to adjust the focus.
Yeah.
But when you start talking about the sun or stars, focus on infinity.
Yeah, for sure. Now, of course, the event that happened on Friday night, when by the time we got through Saturday and the Saturday evening, there was a brief
flare
activity, but it was only on the order of half an hour. In fact, we caught that myself from my house. And by the time I got my camera all geared up, because I'd taken it all apart, by the time I got everything all put up and got outside, the event was over that quick.
I was watching on the Aurora cam, so I got to see it happen before some clouds moved in.
Yeah.
And but that's what I was talking about. The KP index was still 7, but the BZ field, the BZ was back north.
Right.
And even here in North Dakota, we did not get much in the way of Aurora because of that.
Yeah, so that was pretty well it for the event, right? So the event's over. But the good thing about it, if you're a lover of Aurora, is that the sun is still ramping up its activity. We haven't, solar max is one of these things you can't predict precisely. It's once we're past it by several months, then we can say, that was solar max that occurred back 6 months ago, whatever. Right?
I will go back to this picture because it's showing we've got plenty of sunspots coming up. And if you see this bright region that's in the lower left of the sun, that's rotating towards us, and it's probably associated with a large sunspot complex. I may be wrong there, but I would imagine that type of active region has some kind of sunspotting going on. So we're not out of the woods, if you will, yet.
Yeah, and actually, if you look at the recent, like the one that's been taken the last few hours, you can kind of see that there's another region north of that, right? The way that this image is projected. So there is a potential for another large complex. But the other thing I want to mention is this sunspot complex that's 15 times the size of the Earth. You could easily see that with the unaided eye.
Right.
In fact, if you have any solar eclipse glasses, don't throw them away. You can look at the sun, and for things like you've seen here last week, you could easily see the dark spot on the sun just by looking through those solar eclipse glasses.
It's impressive. I mean, this is why I love keeping those things around, because every now and then you can go, is the sun doing anything today? And you can throw them on and see all the sunspots.
Yeah, unfortunately,
the bigger ones.
Unfortunately, this happened after my class was done for the semester, my astronomy class.
Oh man!
Because it would have been a great thing to take everybody outside and let them look through those solar eclipse glasses at the spot on the sun. But unfortunately, it was a little bit too late for that.
And I'm sitting here going, I would have loved to have. There's a thing called line splitting, and if we'd have had a helium D line filtered telescope, that's a particular color of spectra color that helium gives off.
You're thinking of sodium?
Or a sodium line. Yeah. And I would have loved being able to see if we could see some Zeeman splitting where the
magnetic field.
The single line splits out into several due to the strength of the magnetic field at those spots.
Yeah.
I would have loved to have seen that if we could get it. But
I'm sure some observatory that specializes in solar observations have all those measurements.
Oh yeah.
Guaranteed.
But these are the fun things that you can do when you start seeing things like this.
Yeah. So this was a real unique event in some sense, right?
Mm-hmm.
It hasn't happened for many years now. But, stand by because there's a chance that it can happen again. In fact, it can be even more powerful. In fact, the one that we always talk about when we talk about events like this is the Carrington event.
Oh,
right?
the Carrington
event. We're always
event.
comparing it to the Carrington event. You didn't know where I was going with that.
I didn't realize where you were going with that one.
So this is an event that happened way back in 1859.
I'll go back to this picture.
Yeah, so that was September 1st into September 2nd. 1859. I'm going to say a little bit about it near the end of the podcast.
Okay.
But the sunspot, it was a drawing made by Carrington himself. I think Robert Carrington is his name. And the sunspot that he drew, we can get a rough idea of the scaling of that. And this sunspot here is actually a little bit larger than the Carrington sunspot that caused a huge display of aurora when it went off. And in fact, there are reports where people in Boston, using the telegraph system at the time, there was no telephones.
Caught on fire.
Well, they were communicating, not speaking, but communicating with the telegraph system in Portland, Maine. And both of them had their source of power, their DC power, their batteries disconnected. And the information was traveling along the telegraph wires from the current induced by the aurora activity.
Right. And I've heard tales that they had telegraph wires catching on fire.
Yeah.
And that's because there's an induced current. When you get the magnetic field changing rapidly and you've got metal conducting wires stretched across a large area, you will get electric current going in there. You in fact can, if you live in the north, the real north, Alaska and northern Canada and everything. I've heard tales of people going and hooking up the old style telephones to the barbed wire fences and listening to the aurora because of the induced currents in the barbed wire fence.
Too bad it wasn't powerful enough that you could actually get useful energy out of that.
It is. It's a shame.
What a natural way of generating pollution-free energy.
But it doesn't happen often enough.
No, and it's not powerful enough that would,
Right.
that you could. But I mean, if you want to talk about natural stuff, going down a little bit of a rabbit hole here.
Yeah.
Lightning.
Lightning.
If we could find a way that can harness some of that electricity,
Yeah.
right? If we had a storage capability,
Have lightning farms.
right? Because in Florida, I imagine, you
Yeah.
could recharge everything. The grid would power the United States easily, right?
Right.
The problem is, how do you store that huge amount of
And-
current, of flow of electrons, over a very short period of time?
That's why we're trying to find something other than batteries.
Yeah.
Is because that is a problem. A battery can only hold so much.
Yeah, it wouldn't be able to hold that.
And building a bigger battery doesn't help because there's only so much. There's diminishing returns on it, like so
Yeah.
many things.
But talk about free energy.
But yeah,
So someday in the future, maybe we will
Maybe.
harness that or find way at least.
Yeah.
I mean, who knows, right? So
I mean, I'll throw out a topic for you to do some research on your own and everything: molecular switching, and that's where we could store some of that energy in a chemical process. But outside of batteries,
right.
batteries is still a chemical process, but there are other chemical processes.
Well, even the natural movement of water, tides,
Mm-hmm.
right? The up and down of the water can generate electricity, and people try to harness that.
Right,
It just takes a large amount of money. Overhead is extreme right now.
right.
So is it really worth the cost of it? That's where it's
That's the problem.
That's the problem, right?
There's a lot of sources of energy. Is it worth the cost?
Same as solar panels, solar energy. I mean, we make solar panels more efficient all the time as we learn more about materials,
Yep.
condensed matter physics, essentially. And it comes to some cost breaking point where you can make solar panels so cheap that then they become worth it
Right.
compared to our other cheaper forms of energy, but ones that are worse for the climate or for the environment.
They've got to become cheap enough, or I guess I should say, or efficient enough.
Right.
They can be costly, but if they're efficient enough for that cost, they're worth doing. Or they can be cheap and not as efficient, and you still break even on the cost.
Yeah, and that'll happen. I mean,
It'll
people
happen.
are always developing
Yeah.
the R&D that's going on in that type of line of work, and many others. Right?
I'm
So-
for solar power. I'm still a fan of just using it to convert water to steam by using parabolic mirrors to direct to a target that's full of water and turn a turbine with it. But
Yeah. Well, even turbines. I mean, we make them near here,
yeah,
as you know, and those are still. I mean, the wind farms are not that cost effective, as my
No, they're not.
understanding. I could be completely wrong, but the amount of money that it costs to put up the farm and to maintain it
is
is still too much.
yes.
It's a great idea, right? You can use the wind to. I mean, it's an old idea, right?
Yeah.
People have used that forever,
It's worth exploring, but
right? I mean, people have had wind farms,
Yeah.
just a personal type of thing when they live off the grid and stuff. Same with solar panels.
right. And when I say turbine, I was meaning like our coal-fired plants.
Yeah.
They heat water, turn it into steam, turn
right.
a turbine.
Right.
And you can do the same with solar in that you use parabolic mirrors directed into a target that's full of water, usually flowing water, converts it into steam and
Well, you could just use
use
if
steam
you're
power still.
right. You could just have a large Hoover Dam everywhere, right?
Right.
I mean, just using the flow of water itself to turn a propeller
Yep.
that creates electricity, right? I mean,
Absolutely.
it's just standard E&M type of stuff.
So these are all ways that we could generate power.
And nobody
The
says you have to
question-
do one thing, of course, right?
That's exactly.
Right? You could have 50 different things or 50 different ways of generating pollution-free energy,
Right.
and it's the combination of all of them that would supply our electrical needs
Right.
going forward into the future.
It's just right now, let's face it, coal and natural gas are the easy ways.
Yeah, it's a lot cheaper.
It's a lot cheaper.
Yeah, for sure.
I think that'll change in the not too distant future, but for right now, they're just cheaper.
Yeah, I mean, it's going to be a huge period of transformation into something else.
Yeah.
That makes it, I'm talking about things that worthwhile, not to jam it down people's throats and
Right.
and they go bankrupt because they can't afford to heat their home or something, right? I mean, that's not fair.
That's not right.
So there's a
agree.
ways of handling this society-wise, right? So
Right. No, I agree. I'm just pointing out that it's changing, folks. The landscape on how we produce our energy is changing.
well,
And it's a good thing because we're only consuming more and more energy as we go along too. So.
well, 200 years from now, I'd be extremely surprised we're doing the same old thing as we are today.
Oh, absolutely. Absolutely.
So, think of it that way.
That would be surprising.
Now, there's been other big news
Mhm.
lately, at least things that we like to keep track of, and that's our return to the moon.
Yes.
Obviously, the moon went through a period back in the 1960s, essentially, where it had a lot of spacecraft that visited the moon from the Earth, including ones that were manned by humans.
Right?
And that's kind of turned back now. I mean, we've gone through a lull period in the 70s and the 80s and started to pick up in the 90s where we saw the moon as a place worth exploring once again.
Right.
And that's only ramped up. And here we are now in 2024. And
we're
there seems to be a lot of stuff going on.
We're sending a lot of stuff.
Well, it is. And it's not just the United States. It's
Right.
basically the United Nation of exploring the moon in some sense.
It wasn't the United States back then. It's just we'd sent people there and got the lion's share of the notoriety for it. But
Well, it'd be the Soviet Union,
Soviet
and
Union
the
and
United
if-
States, but that was it. It was just the two countries.
was it just them?
It was
I
just
thought-
them.
I
No one
thought-
else.
Okay.
Nobody else at the
I thought,
time.
Britain or somebody else. was
No,
doing
not
it
to the
too.
moon.
Okay.
So, but now, of course, there's been other countries, and we had Japan recently go to the moon independently.
India.
China has done it. India has done it.
India's wasn't as successful as it should have been.
Yeah,
and
and even
hopefully-
Russia and the United States are
Yep.
back in the game again. And we know, of course, about the Artemis project,
Right.
the idea of sending humans back to the moon eventually to return. So all of this stuff's happening. In fact, China is kind of does this slow, incremental planning, so it's well thought out in some sense. At least it seems to be from the outside.
Right.
And they've taken another step in their moon exploration program. This was the launch back in May the 3rd of the Chang'e 6 spacecraft. And this is a lander, and actually it has a return probe with it.
Okay.
So the idea is going to land on the moon, pick up some of the soil and rocks, and then send that meet back up with an orbiter that's actually orbiting the moon. So it separates when it's in moon's orbit. The lander goes down, lands on the moon, of course,
Scoops up
scoops up some material and stuff, and then part of that lander then can lift off. It uses the bottom part as a launch pad, similar to the lunar module design in the Apollo program.
Right.
And then that rendezvous with the orbiter, and then that goes off towards Earth and lands and get your soil that way. They've done that already.
They've done that. So what's so special about this one?
What's so special about this is that they're sending this spacecraft, the lander, to the far side of the moon,
Yep. And I like your language.
not the dark side.
Right. Because
Now, if you do a search for Chang'e 6, let's say on Google, you will see links from different newspapers around the world, and I'm not going to mention some of them, where China has just recently sent a spacecraft to the dark side of the moon. Now, Robert, a few weeks back, even NASA Administrator Bill Nelson was asked by Congress, why doesn't the United States go to the dark side of the moon also? And he said, it's dark there all the time. Why do we want to go there? We go on the near side of the moon where it's in daylight.
because it's not dark all
And
the time.
that is totally wrong. In fact, not to pick on anybody in particular, but Barack Obama, back when he was president, had a comment on his Twitter account at the time. It was Twitter at the time, not X.
Yeah.
That he congratulated NASA for taking an image of the dark side of the moon.
Couldn't have taken too good an image if it had been dark.
Now, when you look at the image, of course, you can see lots of craters, so they must have had a powerful flash bulb went off on the
Right.
camera to illuminate that side of the moon in order to get that nice picture.
Or maybe it was done at a time of new moon where that side of the moon is facing the sun, and
Well-
is therefore brightly lit.
Well, not to take anything away from this mission.
Right.
This mission is what we need to do to go to Mars.
Absolutely. Yeah.
Now, there is the thing on the sample return mission to go to Mars, but it's been so over budget. NASA's now put out fielders to look for ideas to reduce the cost and the time to get to Mars.
Right.
So the original plan, I don't know, was well over $10 billion, and it was taken to the 2030s. You know, it's like, I don't know, I'm not going to pick on engineers. You give an engineer and say, I have an infinite supply of money. I want you to build a spacecraft to go to Mars, pick up some soil, and bring it back. They'll come up with some elaborate thing that might cost $10 trillion for all I know.
Right.
Because they want to jam-pack it with everything, all of the ornaments, right?
Yeah. And I think that's scientists that want to do that.
Well, scientists would like to have every instrument you can think of. They want
Absolutely.
all of earthly laboratories and transplant them to Mars,
Right.
which would cost a lot of money, obviously. So NASA decided to reissue this call to ask for proposals for a greatly reduced type of mission in terms of cost and time that it would take to get there. And I can't blame NASA for doing this.
Absolutely.
They were feeling the heat. And I think this was part of why NASA administrator was in front of Congress answering questions about going to Mars, going to the moon, what China was doing versus what NASA is doing, so on and so forth. And he got into this, I don't know if you realized at the time, this statement of where he said that the far side of the moon is the dark side of the moon. And I blame Pink Floyd with that.
I blame Pink Floyd because Pink Floyd is the only dark side of the moon, folks. You know, it's just the far side. It gets lit up every 2 weeks.
So we blame Pink Floyd because they came out with an album back in, what, the 70s?
70s.
That title was The Dark Side of the Moon. And it had a lot of good music on it. If you
Great music.
If you like
I highly
that type
recommend
of music.
the album.
Yeah. but that whole title, The Dark Side of the Moon, is just bogus. It's wrong.
Right.
It's like saying that only one half of the Earth receives sunlight, the other half never ever does. It's always in the darkness, and that's not true at all.
Right.
In fact, the way the moon goes around the Earth, the moon receives about 2 weeks of sunlight equally on all sides of the moon.
Right.
So a day on the moon is about
2 weeks.
Roughly 28 days long.
And folks, I'm going to address another thing about the moon. The moon does rotate. It rotates once every revolution. Every time it goes around the Earth once, it rotates once. So the moon does rotate. It just rotates at the same speed it goes around Earth.
And because of that, then the one side of the moon always faces the Earth. Yeah. And so we get this notion that we think the other side is somehow the forbidden land. It's always in perpetual darkness. Don't ever go there. You'll never come back, you know?
Yep.
This kind of thing. And it's totally wrong. In fact, if you ask somebody, does the Earth display phases if you were standing on the moon? Back in the Apollo program days, I think a lot of people would say yes. Why? Because I see images that are broadcast from the moon. And when they show the Earth is not a full Earth. It's a gibbous phase usually, right? And so I know, yes, the Earth would display a system of phases. But today, because we don't have that direct sort of experience, people get confused, younger people, and don't really know if the Earth would display phases if you're standing on the moon. In fact, it's the opposite.
It's the opposite of the moon phases because the full Earth would occur on the moon when it's at the new moon phase for Earth.
Yes. So it's always opposite. So if the moon is full moon phase tonight, then that means if you were standing on the moon, the Earth would be at new phase because it's towards the line, towards the sun.
Right. And
so the dark side of the Earth is facing the moon at that particular point, right? You want to think of it like that.
So I know it gets confusing, but you know, these are the way things are, folks.
Right. So when the moon's at new moon phase,
then
if you're standing on the moon facing the Earth, it would be
a full Earth.
A full Earth phase.
Yep.
So it's just the opposite. That's because you're 180 degrees away, right? You're on the other side when you're standing on the moon versus standing on the Earth looking at each other type of thing. So yeah, the Earth does go through a series of phases. And no, there is no dark side to the moon.
Yep.
As people try to and how do you get rid of that?
I have no idea how we get rid of that. You know, I mean, so many things go through phases. Mercury goes through phases. Venus goes through phases. Why would it be surprising that the Earth goes through phases and that the moon actually does rotate? I'm confused on how these things get into people's heads.
Well, I mean, you can go down a rabbit hole here and talk about a lot of other things. A lot of things like, for example, horoscopes.
Right.
Why is, before everything went online, why did all major newspapers in the world essentially have a daily horoscope when we know horoscopes, which is astrology, is total bunk?
Yeah.
It's been study after study after study done about astrology and horoscopes and how it relates to things that happen in your life, and it's nonsense, right?
Right.
There's absolutely no connection at all. There's nothing to it. Now, if you want to believe that there's something to it, that's up to you. I'm talking from the scientific point of view. There is absolutely nothing to it.
Right.
It's all bunk. And yet all these papers, demand, the readers demand, of course, that the horoscopes be put in there. Now, most people probably today take it as a sign of entertainment. Oh, let's read my horoscope, what it says today.
I play around with the stuff for that.
Just for fun, right?
Just for
but
fun.
I'm not taking it seriously. Just because Uranus was in the constellation of Aquarius at the moment I was born or something like that, that now influences the rest of my life somehow, right?
Right.
That's just total garbage.
I used to try to point out to my students when I was teaching astronomy labs, I would go into them and point out that if you go stand 20 feet away from one of these huge SUVs that used to be built back in the early 2000s, you have more gravitational attraction to that SUV than you do to Jupiter.
Well, you can calculate that too. I mean,
You
the
can.
equation to calculate the force of gravity, just think
It's
of
simple.
Newtonian physics, is extremely, simple.
It's extremely simple.
it's very easy
You
to
know how to
do this.
multiply and divide.
Yeah, a child could do the calculation.
Yeah. But, your SUV has more effect on you than Jupiter does,
Yeah.
much less the stars. So,
But I mean,
Yeah.
in terms of the history of astronomy, there was a direct tie-in to astrology
yes, there was.
because, the courts and the different kingdoms, they demanded, forecasts and depending on what was going on in the sky at the time at certain times, right?
Johannes Kepler was an astrologer
Yeah.
as well as being the one who developed the 3 laws of planetary motion. So,
And he made money from that, I'm sure.
and he made money from it. It's how he financed his astronomy pursuits.
Yeah. But but astrology has been shown over and over and over again to be wrong. Yet a lot of people out there still believe in it. But then there are people out there who believe that the Earth is flat, that we never went to the moon, human-wise, and
Yeah.
then you can name all kinds of things, right? That
Absolutely.
there are 400 people involved in the shooting of John F. Kennedy. What are some of his conspiracies, right?
Yeah.
That UFOs have been here. There's aliens amongst us.
Yep.
We reverse engineer everything. That's why we got stout fighters and bombers, because it was all reversed alien spacecraft,
Yeah.
technology, all of this kind of stuff.
if you're getting into conspiracy theories, if you throw a rock, you'll hit one.
Yeah.
Okay. I'm sorry to say that, but if you really, you don't have to dig much to find one. So,
Well, speaking about rocks,
okay.
so getting back to this mission from China, the Chang'e 6, this slide actually illustrates a little better where it's landing and what the sample return mission, how it works. So on the left side, we see that's the moon, obviously, and looking at the South Pole region. And you can see the Chang'e 6 landing site is that red square that you see there, sort of the upper right of center and the upper part a little bit. So that spot is on the far side of the moon, but it's closer to the South Pole. It's a little bit off. It's not right on, but it's in that general vicinity, right?
It's on the South Polar region.
Yeah, put it that way. But the thing about on the right-hand side is an artist drawing here. It's not an image taken from the moon or anything like that, but it gives you an idea how this thing will work. So we see the lander, and then once it collects the sample, you can see the sample return spacecraft that will lift off from the moon and join up in rendezvous, that is, with the orbital spacecraft, and then go from there back towards the Earth.
At least that's the plan. And I point that out because any of this stuff is incredibly tricky.
Well, so you know what's going to happen, right? This is proving, right, a mission. It's a laboratory to test the technology.
Right.
But I wouldn't be surprised that countries like China, for example, will take this basic technology, enhance it, and send these devices to Mars
Right.
to do what we
Absolutely.
want to do, right? That NASA's trying to do. So maybe something like this can be launched for $1 billion, right? Instead of $10 billion.
Right.
It may only take 10 years, or maybe less than that. Maybe it only take, I don't know, 5 years or something to pull off, not 10 years or whatever by the time
Right.
it gets back. So we'll see, right? But this is, if you prove things on things that are local, like the moon.
Right.
And then expand your horizon, no pun intended, and go much further afield, like to Mars
Well,
and other places.
I will sit here and go, I don't know why it's causing that big of a stir when we've done it with asteroids.
Yeah,
So,
exactly.
I mean, I know why it's causing a bigger stir, why it's a bigger problem. You've got a deeper gravity well
Right.
that you've got to get into safely and then out of safely.
Yeah.
So I get why it's actually a harder job and a more complex job. Even the moon is much larger than a large asteroid.
Well, the Mars one that the NASA was initially planning. So its detail is you land near the caching that's going on with the Perseverance that's on Mars now, right?
Right.
So it's caching these samples, but then that means you got to go to all these numerous locations
And bring them back.
and bring them back to some
Central,
spacecraft, and
yeah.
that will lift off from the Martian surface to get into orbit, join up and rendezvous with another spacecraft that'll send us on its way to Earth, which we can all do. I mean, we've done that, right?
Right.
But the thing is, how do you cache these samples? They even thought about, like the Dragonfly, to have helicopters
Come around and pick
that
them
would go
up.
up and pick up all
Yep.
the like you're making it so incredibly complex, and as soon as you make it complex, that means it costs lots of money.
Lots of money. Yeah.
You just have a simple device that goes down, grabs a bunch of stuff, and then takes off again.
Right.
Right?
That are in the case of what the Perseverance is doing, and I have no doubt this is actually what was in mind. I'm sorry to say this, but I think they would have eyes intent on having boots on the ground, because people can go around and pick up these caches easily and in a short amount of time and then lift back off with them. But I think that's what the actual goal on the horizon was. It's not going to happen, folks.
Well, it may happen. It's just not going to happen in
In
our lifetime.
In our lifetime, yeah.
So you could imagine we're driving on our Martian buggy on the surface, going around with our GPS system that
Yep.
we're going to have set up for Mars. And they're talking about doing that already.
Right.
Have satellites in orbit around Mars to act like a GPS system so we can determine coordinates very precisely on the surface and go pick up all of these caches of samples plus
Yep.
additional ones, obviously. But, that's just the natural progression of technology.
And it's what we do as human beings. I mean, why did Hillary climb Mount Everest? Because it was there. We are natural explorers. We want to see what's on the other side of that hill. We want to see what it looks like from the top of this mountain. We want to go to these places and see for ourselves. And, I'm going to sit here and say that's a good enough reason on its own.
Well, if you could take something like this, the Chang'e 6 or equivalent sort of thing that we can design and build, of course, and have done in the past, and send these, like, if you can build them cheap and put them up in a really powerful rocket, right?
Right.
Like the one that Elon Musk is working on,
Right.
and like Starship, for example, and then send them to all kinds of places in the solar system.
Yeah.
You're talking about the gravity well is a problem. Like if you land on Venus, it's hard to get off of there, right? Be like the Earth, for example. But what about multiple moons of Jupiter and Saturn
Absolutely.
and Uranus and Neptune? Those
Right.
moons, right?
And the Falcon.
And many asteroids and several comets and so on and so
The
forth.
Starship and a lot of these other planned rockets are powerful enough to get us there.
Yeah, you could send out multiple spacecraft at one rocket launch.
Yeah.
They'd be
Because
all-
that's been the problem for us getting out to the outer solar system is since the Apollo and the Saturn V, there hasn't been a powerful enough rocket
yeah.
in manufacture to get us out there.
And even with the advancement of technology, you can't make, you can make nanosats and these microsatellites and all these kind of things to get them out there. But still, they're big enough that they require a large rocket.
That's it. Yeah.
And you want to send out almost like a constellation of these probes at once, almost like Starlink satellites that get sent up, right? You have 20 of them
So
take off at the same time, right?
So why did we let our heavy rocket, our big rocket technology die? And the answer is they're expensive. They take a lot of time, a lot of effort, and a lot of money to build a rocket that size. See Elon Musk.
And to be
SpaceX.
to be truthful, you're talking about the early 70s.
Right.
If you're talking about the Saturn V. And technology compared early 70s technology to today, a huge advancement, right?
Right.
So
So
we
it's a lot cheaper now than it was then.
Way cheaper. In fact, you can make, in some size box, a way more powerful, probe than you could back in the early 70s. So
Right.
in some sense, we really had to wait for technology
To catch up.
to our dreams.
That's it.
That's essentially what we had to
Yeah.
do. But
So-
those dreams are still there, and they will be fulfilled. It's just a matter of time.
Just a matter of time. Just a matter of time and people wanting to do it.
That's why it's so exciting now, where there seems to be this big push now to get back to the moon. And obviously the moon is a stepping stone. Imagine if we didn't have a moon, where would we go? What would be the goalpost then, right?
Right.
How could the United States and the Soviet Union and the 60s compete with each other in the space race if there was no
moon?
We'd have to go directly to Mars or something, right?
We'd have our asteroids, and it's like asteroids are hard because there is so little gravity.
Right.
So,
So if
I'm
you
glad
journey
we have
in
a big moon.
if you go to an asteroid, you don't plant your flag on the asteroid.
Because you'll launch yourself into space.
You wrap your flag around the asteroid.
Right?
Shrink wrap the asteroid with the American flag.
Because even a big asteroid, if you sneeze too hard, you've launched yourself out at escape velocity.
Well, you know what would have happened back in this? Probably would have took till the 70s to do it, but we would have done it. We would have went to Mars and tried to
Right.
beat the Soviet Union to Mars.
To Mars.
So we would have had people on Mars already if there was no moon.
If there was no moon, yeah.
Right.
I won't disagree.
I think it would have took a lot longer to
Yeah.
do that. But
And I think it would have been a one-way trip.
who knows? I mean, a lot of people thought the moon would have been a one-way trip too.
True.
In fact,
it almost was for one Apollo mission.
Well, I know that President Nixon at the time, who was the president when Apollo 11 landed, he had 2 speeches prepared.
Right.
One for the successful landing of Apollo 11 and return of the astronauts, and one for unsuccessful. So you always have that in the back of your mind. You're always prepared for that kind of situation, that scenario.
Absolutely.
So, and that's no different, I think, going to Mars. It's just that instead of having the 60s, it probably would have took till mid-70s
Mid-70s,
to
80s.
develop that technology. But who knows? You could think Skylab, right?
True.
So that was developed, in the early 70s.
And that might have been it. We'd
That
had a
might have
space
been-
station
yeah,
up there.
they would send the Skylab would have been launched on its way to a Mars,
Right.
intercepting trajectory, and you just have a spacecraft that goes from the Skylab in orbit around Mars to land on the surface, do its
Yeah.
thing, come back, and head back to Earth.
We need to be in charge of this.
Yeah. I mean, it would have cost a lot of money, obviously. In fact,
right.
it's going to cost a lot of money even today to do
Right.
this stuff. It's never cheap.
It's never cheap.
But, should we do it? And there's, people argue there's a lot of spin-offs that come from doing those kind of development, whether it's microelectronics, advancement in computer technology, all kinds of other things. Some people laugh and say, no, the money that was put into the Apollo program was not all put into the spin-offs, like, you know what I mean?
Yeah.
You didn't get all your money back. Some people argue, for every dollar that NASA spent, it comes back $8 or $9 into the economy to boost it.
Right.
So it's a real advantage it's a good investment into the economy,
Yeah.
the space program itself. And of course, some people would say, why are you wasting all that money going to the moon? Why don't you feed the poor and the hunger here on Earth? Well, it's not like you take billions of dollars and stuff them inside the capsule and you send that out into space.
Right.
That money is spent here on Earth to pay for people to work on these things, right?
Yeah.
To advance our technology, to hopefully improve our lives, to make the economy better, to keep up with other countries, for example, AI,
Yeah.
right? Or quantum computing. All of these things are out there that we're striving to get to today.
Yep.
I mean, and if we don't, other countries may, and they'll have a great advantage economic advantage over us in the future, right?
And as I always try to point out to people is why are these things viewed as zero-sum games? In other words, why is it all or nothing? We do this and we don't do anything else.
Yeah.
We've got enough resources that we could do all of it if we tried.
Well, what's the description of a advanced society, if you like we think we are?
Yeah.
Is that we can do multiple things at the same time. We can multitask, right?
We can multitask.
We can have great museums and architecture as well as exploring the universe at the same time, right? As well as trying to feed the hunger to solve the homelessness problems and so on and so forth.
Cure cancer as well as
All of
explore
that
space.
stuff can
We
be
do
done
it
all at once. I mean, if we were all had to do one thing, it would be a boring life.
It would be a boring world.
We want to be doing all these multiple type of things, and
Right.
that is the hallmark of a great society.
Yep. Speaking of which, doing all these things,
Yeah.
right? Because
Right.
it's about that time.
It's getting there. If you're interested, of course, in science, if you're interested in arts, if you're interested in anything else in between, of course, higher education is one of the things you can go to learn after you're finished high school. And that
Yep.
includes, of course, coming here to the University of North Dakota. We have
Absolutely.
lots of programs. In fact, so many of them that we had to take a whole podcast just to talk about the things that happen at the University of North Dakota. But we
Yes.
have both online courses and also things that you can get involved into on campus as well, the more traditional way, if you like. And if you're interested in that, of course, please consider coming to the University of North Dakota. And if you
Absolutely.
happen to
Yes.
be around on campus sometime, please look Robert and I up.
Look
we
us
are
up.
in the physics and astrophysics department.
Mm-hmm.
So you can find
We'll
us
be
there.
happy to talk with you
Definitely.
and about all of this stuff. So
Now, as I mentioned already, our next podcast will be in September.
In September.
So after the summer break is over with hopefully a very new and fresh view. We're hoping to have some renovations done in the room that we do the podcast. We will
Right.
see.
we will
Always
see if
trying-
it happens.
Always trying to think of ways to improve things. We're
Mhm.
also looking at expanding, going beyond YouTube,
Right?
branching out into other platforms and social media. So we're going to try to do that as well. So we'll see how that works out.
Yep. We're going to try some new tricks.
Yeah.
I'm thinking.
Exactly. So
So,
we'll see. Hopefully,
we'll see how it
to
goes.
improve the way things are run around here. Also, we like to do some remote type of broadcasting.
That's what I was talking about. New tricks.
Yeah. So maybe
Some
we'll get a
remote-
chance to get out to the observatory and do some stuff.
Yeah,
And
show y'all what it looks like.
exactly. Now, one of the things we started with today, of course, is the exciting thing that happened on Friday evening with the Aurora and the large sunspot that was on the sun, and we talked about the Carrington event. And just to kind of finish up, we always leave you with a quote or an excerpt or something like that. So today I decided to talk about what was actually seen back in 1859 during the Carrington event.
Okay.
This is actually an excerpt from the Baltimore American and Commercial Advertiser, which was a newspaper that lasted just a few more years later before it went defunct.
Yeah.
So it's no longer out there.
That used to happen all the time in America.
Yeah, come and go, these
They come
things.
and
And
go.
so this is a description of what people saw from Baltimore at the
Okay.
time of the Carrington event. So I'll just read what was published at the time. Those who happened to be out late on Thursday night had an opportunity of witnessing another magnificent display of the Aurora lights. Now, just to step inside here a little bit, another magnificent display. In fact, in that time period, the sun was going through solar max. There was numerous these type of auroras.
Yes.
This was not just a single one-time only type of thing that happened.
Right.
So this had been happening fairly recently at this time period,
Yes.
which is, and so that's all consistent with the sun going through solar maximum,
Solar maximum.
at that
Yeah,
time.
Yes.
So to continue, the phenomena was very similar to the display on Sunday night. So there's another hint that this has been going on recently at this
Yeah.
time period. Though at times the light was, if possible, more brilliant and prismatic hues more varied and gorgeous. The light appeared to cover the whole firmament. So from horizon to horizon, Robert.
Right.
Apparently like a luminous cloud, through which stars of larger magnitude indistinctly shone. The light was greater than that of the moon at its full.
Wow.
So brighter than the full moon. Imagine that.
Imagine that.
And we did not have that on
We
Friday
did not have
night.
that. Yeah.
But that is incredible. But had an indescribable softness and delicacy that seemed to envelope everything upon which it rested. Between 12 and 1 o'clock, when the display was at its full brilliancy, the quiet streets of the city, resting under this strange light, presented a beautiful as well as singular appearance.
Nice. And it was a lot darker skies even in town back then, folks.
Yeah,
So keep that in
you can
mind as
imagine
well.
the view that people had.
Oh, yeah.
So you never know what is going to come in the next few months or a year or so when we go through the solar maximum.
Yep. Keep
So-
your eyes to the sky.
So with that, please give us a thumbs up if you like this podcast, and we'll see you next time.
See you in the fall.